So what we're going to do is look at this paper. We want to analyze the types of questions. But now, as we're analyzing this one, we're remembering that this one is not coming. Power series is not coming for the test today. So power series is out. Okay, power series is out. It is not coming for the test today. What we're going to be doing is there's a type of question which hasn't been coming for the last tests, but we do expect it because power series is not in today, okay? Which is for homogeneous differential equations that are second order. Let's talk about the big questions, okay? I'm ignoring these ones, these small ones with small marks for definitions. We want to look at these ones with big marks, okay? Here is one, then here is the other one, then here is the other one, then of course this fourth one is now out because power series is not coming. So okay, which ones are we looking at? These three. How do I quickly recognize? We don't want to waste time. This is so easy. It is impossible for us to be tricked by this thing. We're going to get marks just from the get-go because everything is simple. So we know that a differential equation is just an equation which has a derivative, right? So now you're going to look. You see, the good thing about these differential equations is they're actually going to tell you the method to use. If they don't, I'm going to show you, and so you see how easy it is, okay? Here is the first differential equation. Here they give you a differential equation and they say please use the variable separable method to solve it, okay? You're going to have to do that. You just go ahead and you use variable separable method. Is common sense. The differential equation is this one. dy dx is equal to this, and they say use the variable separable method. Okay, so first let me just say, in this video what I'm going to do is to show you the 4 methods, isn't it? Talk about the 4 methods that are coming for this test, and then we're going to start doing the questions one by one, right? So the 4 methods that are coming for this test will be what? Will be method number 1, variable separation, or they can, he's saying variable separable, but it's variable separation method, okay? Variable separation, where you're going to take everything with y, you take it to the side where dy is, and the x goes to the side where you'll be having dx. So y and dy on one side, x and dx on the other side. Then you integrate both sides. You're going to integrate both sides, and then you're going to get a constant c. You put it on the left or on the right, we don't care. And then you're going to find that constant c. You are done. You are done. This is common sense. It's easy, but then you just have to make sure you are good at integration. That is where you're going to be caught out on integration, because you are separating, then you integrate, then you find the constant c. You can put it on the left, you can put it on the right, we don't care. You're still going to find it as the same thing. So variable separation method number 1. Method number 2 is by using what we call the integral factor. We'll see how to do this one. Method number 2 is by using what we call the integral factor. And what I want you to know is for these 2 methods, you're going to really integrate, right? There's going to be some nice integration here. You're going to integrate, okay? Let's see the other one. Method number 3, what is it going to be now? Method number 3, we are now doing for homogeneous equations that are second order, okay? So in here, this is going to be first order. These 2 will be for first order. That means you only have dy dx. You are never going to have d2y dx squared. You can never have the second derivative for these ones, okay? But now for method number 3, you are now going to have first is what you're going to, this is for now homogeneous, for homogeneous second order. Okay, so here we are now dealing with second order now. Here we've done with the first half for first order. Now we're going to be dealing with second order differential equations, and there are the other 2 methods. This method is where you're going to find what we say the d operator form. You're going to find the d operator form. Then you're going to create what we call auxiliary equations, okay? You're going to create what we call auxiliary equations. You solve them, they're just quadratic equations. Then you're going to find 2 values for m, right? Now the value for m is going to depend where you're going to have y, okay? You're going to create your y from the 2 values of m you get, okay? 2 values of m. You're going to get y from the 2 values of m you're going to get. Then you're going to look for constants. So y can have 3 forms, and we'll talk about it. But in here, this is you're going to then look for constants a and b, and you'd be done. Now this is going to be for what? This is going to be for homogeneous. So method number 3 is going to work for homogeneous second order. What does it mean to say they're homogeneous? In other words, it will be equal to 0. If it's homogeneous, that means it will be a second order. It is the second derivative, but it will be equal to 0. And this one hasn't been coming for the other tests that you've been having so far. It hasn't been coming. What comes is going to be the fourth one, which is going to use the things you have learned from this second. You're now going to use them in the fourth one. The fourth one is for non-homogeneous. You're going to get your, what we say, you're going to get your complementary function, plus you're then going to get your particular integral using the table, and you have y. So y is going to be complementary function, which is going to be u, plus particular integral, which is going to be v. Okay, here v, you find it using table. So you're going to use the table and some small games to find v. Then u, you're going to use what? You're going to use concepts from homogeneous. Okay, because you're going to save for the homogeneous. In other words, you're going to create d operator form. You're going to have your d operator form. You make auxiliary equations, you solve them, right? It'll be equal to 0, this u. Then when you have your u, you get your v, and you'll be using a table, but it will still be some d operator form, but it is no longer equal to 0. Then you are going to find your v. Once you find your v and your u, you can add them together, and that is going to be your y. Remember, your y is equal to u plus v, which is u complementary function. How do I find complementary function? Things from homogeneous. Things from homogeneous, where we're doing here. That's how we're going to get u. Then v, we are going to get it from the table, and we'll still use some similar traits. Do you hear me? Then this is going to be the whole test and some definitions. This is going to be your test, and you are done. These 4 things, can you not see them? You can see these 4 things, isn't it? Variable separation and integral factor. Then you're going to have your homogeneous and for non-homogeneous. Okay, for non-homogeneous, you'll be using this idea. Okay, so this is not when do I say I have a non-homogeneous? It is going to be second order. In other words, there's going to be d2y dx squared. There's going to be the second derivative. The second derivative will now be there for these last 2 methods. In the third method, it will be second derivative plus what equal to 0. In 4, it will be second derivative blah 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 not equal to 0. It will be equal to something which is in terms of x. You understand? And you're done. We're going to see how to solve it. Let's go ahead and let's do it. Let's do the questions. I want you to analyze. If you look at here, look here. If you look at the one which they want you to use variable separation, you can see that it is only the first derivative which is there, right? It is, so it's a first order. It's a first order differential equation, and we're going to separate the y's. Go where dy is to the left, and then the x's and dx will be on the right hand side. You integrate both sides, and then you're going to say plus constant c. You find your constant. You are done. Then you're going to go to here, which is going to be finding using the integral factor. I'm going to show you how to find using the integral factor. We are going to create one, and we'll see how. But you can see that the question again is here. There is no second derivative there. There is no second derivative. So the one for integral factor is again not having it. Then here you can see here we now have the second derivative, but you can see that it is not equal to 0. Look at what it is equal to. It is equal to some function of x. Okay, it'll be having something plus y being equal to the other side. We have some things that are in terms of x, and we are going to find our y to say it is complementary function plus particular integral. Then we're going to use that to find our y from here. That's the idea. We're going to have complementary function, which will be in terms of u, which will be the side for y, and we're going to find it. Then we're going to solve our particular integral using the table, which we don't have to cram. Will be given in the test, at least for the test. Now when we're going for the exam, then we'll see how you can put it in your mind, but for the test you'll be having it, and we're just going to apply it. You are done. You hear me? This is simple, right? This is simple. These 4 are coming plus definitions. You are done. You can see here they didn't have the 1 equal to 0. Even the previous test you won't see. It's because the power series was there. But now that the power series is not there, we are expecting to also get the homogeneous ones, which is equal to 0. And it's a walk in the park. Goodbye for now. Let's go ahead and let's do these questions. Bye.